Kandinsky, an improved text-to-image synthesis with image prior and latent diffusion. Text-to-image generation is a significant domain in modern computer vision and has achieved substantial improvements through the evolution of generative architectures. Among these, there are diffusion-based models that have demonstrated essential quality enhancements. These models are generally split into two categories: pixel-level and latent-level approaches. We present Kandinsky, a novel exploration of latent diffusion architecture, combining the principles of the image prior models with latent diffusion techniques. The image prior model is trained separately to map text embeddings to image embeddings of clip. Another distinct feature of the proposed model is the modified MoVQ implementation, which serves as the image autoencoder component. Overall, the design model contains 3.3 billion parameters. We also deployed a user-friendly demo system that supports diverse generative modes such as text-to-image generation, image fusion, text and image fusion, image variations generation, and text-guided in-painting, out-painting. Additionally, we released the source code and checkpoints for the Kandinsky models. Experimental evaluations demonstrate a FID score of 8.03 on the COCO 30K dataset, marking our model as the top open-source performer in terms of measurable image generation quality. How far are large language models from agents with theory of mind? Thinking is for doing. Humans can infer other people's mental states from observations, an ability called theory of mind, TUM, and subsequently act pragmatically on those inferences. Existing question-answering benchmarks such as Tommy ask models questions to make inferences about beliefs of characters in a story, but do not test whether models can then use these inferences to guide their actions. We propose a new evaluation paradigm for large language models, LLMs, thinking for doing, T4D, which requires models to connect inferences about others' mental states to actions in social scenarios. Experiments on T4D demonstrate that LLMs, such as GPT-4 and Palm-2, seemingly excel at tracking characters' beliefs in stories, but they struggle to translate this capability into strategic action. Our analysis reveals the core challenge for LLMs lies in identifying the implicit inferences about mental states without being explicitly asked about, as in Tommy, that lead to choosing the correct action in T4D. To bridge this gap, we introduce a zero-shot prompting framework, Foresee and Reflect FAR, which provides a reasoning structure that encourages LLMs to anticipate future challenges and reason about potential actions. FAR boosts GPT-4's performance from 50% to 71% on T4D, outperforming other prompting methods such as chain of thought and self-ask. Moreover, FAR generalizes to diverse out-of-distribution story structures and scenarios that also require TOM inferences to choose an action, consistently outperforming other methods, including few-shot in-context learning. Aligning text-to-image diffusion models with reward backpropagation. Text-to-image diffusion models have recently emerged at the forefront of image generation, powered by very large-scale unsupervised or weakly supervised text-to-image training datasets. Due to their unsupervised training, controlling their behavior in downstream tasks, such as maximizing human-perceived image quality, image-text alignment, or ethical image generation, is difficult. Recent works fine-tune diffusion models to downstream reward functions using vanilla reinforcement learning, notorious for the high variance of the gradient estimators. In this paper, we propose AlignProp, a method that aligns diffusion models to downstream reward functions using end-to-end backpropagation of the reward gradient through the denoising process. While naive implementation of such backpropagation would require prohibitive memory resources for storing the partial derivatives of modern text-to-image models, AlignProp fine-tunes low-rank adapter weight modules and uses gradient checkpointing to render its memory usage viable. We test AlignProp in fine-tuning diffusion models to various objectives, such as image-text semantic alignment, aesthetics, compressibility and controllability of the number of objects present, as well as their combinations. we show a line prop achieves higher rewards in fewer training steps than alternatives, while being conceptually simpler, making it a straightforward choice for optimizing diffusion models for differentiable reward functions of interest. Code and visualization results are available at the project's website. Improved baselines with visual instruction tuning. Large multimodal models, LLM, have recently shown encouraging progress with visual instruction tuning. In this note, we show that the fully connected vision-language cross-modal connector in Lava is surprisingly powerful and data-efficient. With simple modifications to Lava, namely using ClipVeet L336px with an MLP projection and adding academic task-oriented VQA data with simple response formatting prompts, we establish stronger baselines that achieve state-of-the-art across 11 benchmarks. Our final 13B checkpoint uses merely 2M publicly available data and finishes full training in approximately 1 day on a single 8A100 node. We hope this can make state-of-the-art LLM research more accessible. Code and model will be publicly available at the project's website. UniAudio, an audio foundation model toward universal audio generation. Large language models, LLM, have demonstrated the capability to handle a variety of generative tasks. This paper presents the UniAudio system, which, unlike prior task-specific approaches, leverages LLM techniques to generate multiple types of audio, including speech, sounds, music, and singing, with given input conditions. UniAudio 1 first tokenizes all types of target audio along with other condition modalities 2, concatenates source-target pair as a single sequence, and 3, performs next token prediction using LLM. Also, a multi-scale transformer model is proposed to handle the overly long sequences caused by the residual vector quantization-based neural codec in tokenization. Training of UniAudio is scaled up to 165K hours of audio and 1B parameters, based on all generative tasks, aiming to obtain sufficient prior knowledge not only in the intrinsic properties of audio, but also the interrelationship between audio and other modalities. Therefore, the trained UniAudio model has the potential to become a foundation model for universal audio generation. It shows strong capability in all trained tasks and can seamlessly support new audio generation tasks after simple fine-tuning. Experiments demonstrate that UniAudio achieves state-of-the-art, or at least competitive results on most of the 11 tasks. Demo and code are released at the project's website. MathCoder, seamless code integration in LLMs for enhanced mathematical reasoning. The recently released GPT-4 code interpreter has demonstrated remarkable proficiency in solving challenging math problems, primarily attributed to its ability to seamlessly reason with natural language, generate code, execute code, and continue reasoning based on the execution output. In this paper, we present a method to fine-tune open-source language models, enabling them to use code for modeling and deriving math equations, and consequently enhancing their mathematical reasoning abilities. We propose a method of generating novel and high-quality datasets with math problems and their code-based solutions, referred to as MathCode Instruct. Each solution interleaves natural language, code, and execution results. We also introduce a customized supervised fine-tuning and inference approach. This approach yields the MathCoder models, a family of models capable of generating code-based solutions for solving challenging math problems. Impressively, the MathCoder models achieve state-of-the-art scores among open-source LLMs on the math, 45.2%, and GSM-8K, 83.9% datasets, substantially outperforming other open-source alternatives. Notably, the MathCoder model not only surpasses ChatGPT 3.5 and Palm 2 on GSM 8K and Math, but also outperforms GPT-4 on the competition-level Math dataset. The dataset and models will be released at the project's website. DSPy, compiling declarative language model calls into self-improving pipelines. The ML community is rapidly exploring techniques for prompting language models, LLMs, and for stacking them into pipelines that solve complex tasks. Unfortunately, existing LM pipelines are typically implemented using hard-coded prompt templates, that is, lengthy strings discovered via trial and error. Toward a more systematic approach for developing and optimizing LM pipelines, we introduced DSPy, a programming model that abstracts LM pipelines as text transformation graphs, that is, imperative computational graphs where LMs are invoked through declarative modules. DSPy modules are parameterized, meaning they can learn by creating and collecting demonstrations how to apply compositions of prompting, fine-tuning, augmentation, and reasoning techniques. We design a compiler that will optimize any DSPy pipeline to maximize a given metric. We conduct 2 case studies, showing that succinct DSPy programs can express and optimize sophisticated LM pipelines that reason about math word problems, tackle multi-hop retrieval, answer complex questions, and control agent loops. Within minutes of compiling, a few lines of DSPy allow GPT 3.5 and Llama 213B chat to self-bootstrap pipelines that outperform standard few-shot prompting, generally by over 25% and 65% respectively, and pipelines with expert-created demonstrations by up to 546% and 1640% respectively. On top of that, DSPy programs compile to open and relatively small LMs, like 770M parameter T5 and Llama 213B chat, are competitive with approaches that rely on expert-written prompt chains for proprietary GPT 3.5. DSPy is available at the project's website. HeaP, Hierarchical Policies for Web Actions Using LLMs. Large language models, LLMs, have demonstrated remarkable capabilities in performing a range of instruction following tasks in few and zero-shot settings. However, teaching LLMs to perform tasks on the web presents fundamental challenges, combinatorially large open-world tasks, and variations across web interfaces. We tackle these challenges by leveraging LLMs to decompose web tasks into a collection of subtasks, each of which can be solved by a low-level closed-loop policy. These policies constitute a shared grammar across tasks. That is, new web tasks can be expressed as a composition of these policies. We propose a novel framework, Hierarchical Policies for Web Actions Using LLMs, HeaP, that learns a set of hierarchical LLM prompts from demonstrations for planning high-level tasks and executing them via a sequence of low-level policies. We evaluate HeaP against a range of baselines on a suite of web tasks, including MiniWoB++, Web Arena, a mock airline CRM, as well as live website interactions, and show that it is able to outperform prior works using orders of magnitude less data. Leveraging unpaired data for vision language generative models via cycle consistency. Current vision language generative models rely on expansive corpora of paired image-text data to attain optimal performance and generalization capabilities. However, automatically collecting such data, for example via large-scale web scraping, leads to low quality and poor image-text correlation, while human annotation is more accurate but requires significant manual effort and expense. We introduce ITIT, Integrating Image Text, an innovative training paradigm grounded in the concept of cycle consistency, which allows vision language training on unpaired image and text data. ITIT is comprised of a joint image-text encoder with disjoint image and text decoders that enable bidirectional image-to-text and text-to-image generation in a single framework. During training, ITIT leverages a small set of paired image-text data to ensure its output matches the input reasonably well in both directions. Simultaneously, the model is also trained on much larger datasets containing only images or texts. This is achieved by enforcing cycle consistency between the original unpaired samples and the cycle-generated counterparts. For instance, it generates a caption for a given input image and then uses the caption to create an output image and enforces similarity between the input and output images. Our experiments show that ITIT with unpaired datasets exhibits similar scaling behavior as using high-quality paired data. we demonstrate image generation and captioning performance on par with state-of-the-art text-to-image and image-to-text models with orders of magnitude fewer, only 3M paired image-text data. FreshLLMs, refreshing large language models with search engine augmentation. Most large language models, LLMs, are trained once and never updated. Thus, they lack the ability to dynamically adapt to our ever-changing world. In this work, we perform a detailed study of the factuality of LLM-generated text in the context of answering questions that test current world knowledge. Specifically, we introduce FreshQA, a novel dynamic QA benchmark encompassing a diverse range of question and answer types, including questions that require fast-changing world knowledge, as well as questions with false premises that need to be debunked. We benchmark a diverse array of both closed and open-source LLMs under a two-mode evaluation procedure that allows us to measure both correctness and hallucination. Through human evaluations involving more than 50,000 judgments, we shed light on limitations of these models and demonstrate significant room for improvement. For instance, all models, regardless of model size, struggle on questions that involve fast-changing knowledge and false premises. Motivated by these results, we present FreshPrompt, a simple few-shot prompting method that substantially boosts the performance of an LLM on FreshQA by incorporating relevant and up-to-date information retrieved from a search engine into the prompt. Our experiments show that FreshPrompt outperforms both competing search engine-augmented prompting methods such as Self-Ask, Press et al. 2022, as well as commercial systems such as Perplexity.ai. Further analysis of FreshPrompt reveals that both the number of retrieved evidences and their order play a key role in influencing the correctness of LLM-generated answers. Additionally, instructing the LLM to generate concise and direct answers helps reduce hallucination compared to encouraging more verbose answers. To facilitate future work, we release FreshQA at project's website and commit to updating it at regular intervals. EcoAssistant, using LLM Assistant more affordably and accurately. Today, users ask large language models, LLMs, as assistants to answer queries that require external knowledge. They ask about the weather in a specific city, about stock prices, and even about where specific locations are within their neighborhood. These queries require the LLM to produce code that invokes external APIs to answer the user's question, yet LLMs rarely produce correct code on the first try, requiring iterative code refinement upon execution results. In addition, using LLM assistants to support high query volumes can be expensive. In this work, we contribute a framework, EcoAssistant, that enables LLMs to answer code-driven queries more affordably and accurately. EcoAssistant contains 3 components. First, it allows the LLM assistants to converse with an automatic code executor to iteratively refine code, or to produce answers based on the execution results. Second, we use a hierarchy of LLM assistants, which attempts to answer the query with weaker, cheaper LLMs before backing off to stronger, expensive ones. Third, we retrieve solutions from past successful queries as in-context demonstrations to help subsequent queries. Empirically, we show that EcoAssistant offers distinct advantages for affordability and accuracy, surpassing GPT-4 by 10 points of success rate with less than 50% of GPT-4's cost. DragView Generalizable Novel View Synthesis with Unposed Imagery. We introduce DragView, a novel and interactive framework for generating novel views of unseen scenes. DragView initializes the new view from a single source image, and the rendering is supported by a sparse set of unposed multi-view images, all seamlessly executed within a single feed-forward pass. Our approach begins with users dragging a source view through a local relative coordinate system. Pixel-aligned features are obtained by projecting the sampled 3D points along the target ray onto the source view. We then incorporate a view-dependent modulation layer to effectively handle occlusion during the projection. Additionally, we broaden the epipolar attention mechanism to encompass all source pixels, facilitating the aggregation of initialized coordinate-aligned point features from other unposed views. Finally, we employ another transformer to decode ray features into final pixel intensities. Crucially, our framework does not rely on either 2D prior models or the explicit estimation of camera poses. During testing, DragView showcases the capability to generalize to new scenes unseen during training, also utilizing only unposed support images, enabling the generation of photorealistic new views characterized by flexible camera trajectories. In our experiments, we conduct a comprehensive comparison of the performance of DragView with recent scene representation networks operating under pose-free conditions, as well as with generalizable NeRFs subject to noisy test camera poses. DragView consistently demonstrates its superior performance in view synthesis quality, while also being more user-friendly. Project page, project's website. A long way to go. Investigating length correlations in RLHF. Great successes have been reported using reinforcement learning from human feedback, RLHF, to align large language models. Open-source preference datasets and reward models have enabled wider experimentation beyond generic chat settings, particularly to make systems more helpful for tasks like web question answering, summarization, and multi-turn dialogue. When optimizing for helpfulness, RLHF has been consistently observed to drive models to produce longer outputs. This paper demonstrates that optimizing for response length is a significant factor behind RLHF's reported improvements in these settings. First, we study the relationship between reward and length for reward models trained on 3 open-source preference datasets for helpfulness. Here, length correlates strongly with reward, and improvements in reward score are driven in large part by shifting the distribution over output lengths. We then explore interventions during both RL and reward model learning to see if we can achieve the same downstream improvements as RLHF without increasing length. While our interventions mitigate length increases, they aren't uniformly effective across settings. Furthermore, we find that even running RLHF with a reward based solely on length can reproduce most of the downstream improvements over the initial policy model, showing that reward models in these settings have a long way to go. Large language model, cascades with mixture of thoughts, representations for cost-efficient reasoning. Large language models, LLMs, such as GPT-4, have exhibited remarkable performance in a variety of tasks, but this strong performance often comes with the high expense of using paid API services. In this paper, we are motivated to study building an LLM cascade to save the cost of using LLMs, particularly for performing reasoning, for example, mathematical causal tasks. Our cascade pipeline follows the intuition that simpler questions can be addressed by a weaker but more affordable LLM, whereas only the challenging questions necessitate the stronger and more expensive LLM. To realize this decision-making, we consider the answer consistency of the weaker LLM as a signal of the question difficulty and propose several methods for the answer sampling and consistency checking, including one leveraging a mixture of 2 thought representations, that is, chain of thought and program of thought. Through experiments on 6 reasoning benchmark datasets with GPT-3, 5 Turbo and GPT-4 being the weaker and stronger LLMs respectively, we demonstrate that our proposed LLM cascades can achieve performance comparable to using solely the stronger LLM, but require only 40% of its cost.